Hey everybody, since it is snowing outside and the roads are treacherous and we're not having class, I wanted to present the brief lecture that we were going to do in class on Tuesday the 24th, and it deals with skeletal homeostatic imbalances, and we'll just look at a few diseases. Before we do that, though, I want to show you this video that has really no redeeming value whatsoever. It's just kind of funny. Maybe you'll like it if you're a biology person. Here we go.
Turning to health news, doctors at Johns Hopkins Medical School have discovered that bones are the coolest part of the body. A 10-year study found that although the body has many cool things in it, nothing is cooler than your skeleton.
Just think about it. You have this soft, fleshy body, but inside of it, there's a second, tinier body that's made out of a super hard rock. Our data is conclusive. Bones are very, very cool.
To conduct the study, researchers examined every single body part and determined how cool or uncool it was.
We initially thought the brain might be the coolest part because it's like a computer that runs on food. But when we looked at it up close, it was all gross and wrinkled. Brains are not cool. Bones are cool.
The wide variety of bones is one of the main reasons scientists say they're so cool. Doctors discovered that there are big, strong bones like baseball bats in your arms and legs, hand bones that look like a monster claw, and skull bones that make a scary face. According to the report, even bones' weaknesses just make them cooler.
Bones can break, which sounds like it sucks, but then the bone can heal itself and merge back together, just like the T-1000.
To many in the medical community, the study's findings come as no surprise.
As someone who shoots lasers at bones every day, I know how cool they are.
Doctors did caution that as cool as human bones are, they're not nearly as cool as dinosaur bones. Coming up next, a Red Cross tanker spill drenches wild.
Okay, again, no redeeming value. I just thought that was kind of funny. All right, let's move on.
Everyone loves the pungent scent.
Okay, let's move on into skeletal homeostatic imbalances. And as you can see here, many of the skeletal diseases that we can look at are going to be issues of imbalance between bone resorption and bone deposit. Recall that bone resorption is due to what kind of cells? Osteoclasts, right? So osteoclasts normally and healthily do break down our bone. They recycle the calcium out of the bone so that calcium is available to our body for its other uses. And that process is a normal, natural process. And if we have a balance between bone resorption and bone deposit, then our bone mass doesn't appreciably change. Though there are several diseases, and we'll look at a few here, that actually do have an imbalance between the osteoclast and the osteoblast, or the processes of bone resorption and bone deposit. Let's start with osteomalacia. Osteomalacia actually means soft bones. And in this case, the bones are going to be soft because there's going to be inadequate amounts of minerals, particularly, of course, phosphorus or calcium, or because the parathyroid gland is hyperactive and producing too much PTH, parathyroid hormone. Recall that PTH is going to be the hormone that is going to be controlling calcium metabolism or calcium loss from bones. It also influences calcium uptake from the intestines, calcium uptake from the kidneys. So if someone has too much PTH, there's going to be essentially an imbalance. Calcium is going to be drawn from the bones at too high of a rate, making the bones weaker. The most common cause, though, of osteomalacia is going to be a vitamin D issue, that somebody is not getting enough vitamin D in their diet, or they're not getting any sun exposure. Vitamin D, as you recall, is important because it enhances the absorption of calcium and iron and magnesium from our intestines. And since vitamin D is not found in very many foods, I mean, you do find it like in some fatty fish, mushrooms, you find some vitamin D, but we don't get vitamin D very much from our foods naturally. Most of our vitamin D would be coming from its synthesis from sunlight. We use cholesterol, we take we use the UV radiation and cholesterol, we produce vitamin D. Vitamin D, in turn, helps us absorb enough calcium. So, full circle. Someone can have osteomalacia because they don't get enough sun exposure, or they're getting very little calcium absorption. And as a result, there's not enough calcium in their bones become weaker, and they become more flexible, as you see here. This is a case of rickets. The difference between rickets and osteomalacia is a pretty small one. Rickets just refers to osteomalacia in kids, and osteomalacia is the adult version of bone softening. So a cause can be really a lack of vitamin D, and therefore we get around that since a lot of people can't get adequate levels of sun exposure because they're working inside or because they live in cold areas. We do put vitamin D in several things like milk or orange juice. So if you look at your milk container, it might say vitamin D fortified. That means that we added vitamin D so that when you drink milk, which obviously has calcium, and you have vitamin D as part of that milk. When you drink the milk, the vitamin D helps your body absorb calcium. You have enough calcium in your body. You don't pull it out of your bone. You don't develop osteomalacia. So that is one disease where it really is an issue of calcium imbalance is causing the problem. Osteogenesis imperfecta is going to be a genetic disease. This is going to be a congenital, and let me give you that word, a congenital disorder. That means it's associated with development in the fetus. So this is a genetic condition where someone cannot make a particular kind of collagen. And there's actually 8 different varieties of OI, and we won't get into all the details of this, but they can't make collagen. And we know collagen is a key ingredient in making the bone. You see here how the bone is going to be bowed because of it. This is also called brittle bone disorder, because their bones, because they lack collagen, are going to be heavy or high in the mineral content, and therefore their bones are very fragile and they can break. Someone can sneeze and break a bone. So there's different versions of OI. They go from a not too serious form up to a very serious form. There is no cure for OI. The best we can do is try to prevent fractures. There have been some experimental techniques where they insert rods in people's limbs and their long bones to try to protect them and try to improve the bone strength. But there's not much you can do really if someone has OI. Osteomyelitis. This is a condition where you have an infection of the bone marrow that well, let's just back up for a second. How can someone get microorganisms in their bone marrow? It could be because it got through their bloodstream. We know bones are very vascular, so it could be that some bacteria got into their bloodstream, got into their bone marrow, and caused an infection there. It could be from an infection nearby that spread to the bone marrow. They could have had some kind of penetrating trauma, a compound fracture, and got bacteria introduced. And now there's going to be bacteria growing in their bone marrow. You'll see different classifications for this. They may describe it as, is it a pus-forming form of osteomyelitis? Is it causing extra bone growth? You'll see different conversations and classifications about it. But in the end, it's going to be something that requires prolonged antibiotic therapy. You can't just take penicillin for a week and cure this form of infection. Often this is going to require us to do a PICC line, and you may have seen this before. A PICC line, it stands for a peripherally inserted central catheter, and it's going to be a semi-permanent catheter. Semi meaning it can stay in there for months, maybe even up to a year. But a PICC line allows us to insert antibiotics into somebody and reduce the amount of infection risk. And peripheral, because they're going to put it usually in through a peripheral vein in their arm and run it toward their heart, inject the antibiotics that way. So I'll point this out because someone may have a PICC line, and that's because that's going to be a prolonged treatment. They may also have a PICC line for chemotherapy for cancer. Okay, moving on to Paget's disease. Paget's disease is going to be a disease of someone who has sort of excessive and haphazard bone deposit and resorption. Rather than their bone being laid down nicely and neatly and in a pretty way and giving it nice structural balance, it's going to be like someone randomly sort of threw together bone tissue. The bone looks hastily made. It has a high amount of spongy tissue to compact bone. And as you might imagine, that's going to make the bone somewhat weaker. This is often discovered by accident. Someone may actually have no knowledge or no indication that they have Paget's disease. What you see over here is a more serious case where there's actually going to be some bone deformity, but someone could have Paget's disease and not know it. They're x-rayed for, let's say they may have broken their ankle, and then they discover that this haphazard bone growth is going on in their bodies. It's very rarely going to happen before the age of 40, but about 3% of Americans do have this, and it's caused by either a virus or through some genetic mechanisms. The disease is not really well understood yet. The medications for this are often the same ones for osteoporosis, trying to restrain osteoclasts so that they don't have bad bone resorption and trying to build up bone tissue. And finally, and the one we'll spend just a few minutes on, is osteoporosis, and it's obviously one that we know a little bit more about. Osteoporosis, what I'm giving you here is the pathophysiology. Essentially, what goes wrong when someone has osteoporosis. And you see here some of the main points. The normal homeostatic bone turnover is altered. Again, and I keep stressing this, bone resorption and bone deposit are normally going to be in balance and are normally going to be just fine. We want bone resorption. However, when the rate of bone resorption is greater than the rate of bone formation, we're going to be reducing more bone mass than we're building. This will lead to a reduction in total bone mass, a reduction in bone mineral density, and making the bone prone to fracture. This diagram down here is worth you spending some time on. What you see here is factors that can affect bone mass. Hormones, nutrition, exercise, lifestyle, resorption. Resorption is not spelled right, sorry about that. But these factors can affect how much bone mass we have. Somebody who has sufficient hormones or has adequate nutrition or is getting plenty of exercise, a good lifestyle that is, moving around and active, they're going to have a pretty high bone mass. Bone mass, of course, is going to be leading directly to bone strength. Bone strength is a reflection not only of bone mass, but also of bone material strength and its architecture, how it's put together. Bone strength is going to be a direct factor in whether or not bone is going to fracture. Other factors, so you can sit down here, postural reflexes. If somebody has good reflexes, they're less prone to fracture. They catch themselves when they change position, when they're walking, for example. Padding, if someone were to fall and they have some adipose on their hips, that might actually protect them somewhat from fracture. The frequency of falls, of course. All of these are going to be factors that affect fracture rate. So what I want to stress here is that it's not as simple as is their bone strong? Well, the bone could be strong, but if the architecture is not that good, or it's going to be weak because of its mineral composition, then that does make someone still prone to fracture. So when we're talking about osteoporosis, again, we can make it pretty simple. When bone loss, when bone resorption outpaces bone production. And what you can see here is, look how nice and pretty and smooth this bone tissue is here. Yeah, it's going to be somewhat porous, but that's okay. But look at this. Now you're seeing all these holes, all these areas where the bone is clearly weaker. Look at this section here. That section looks like it's very prone to fracture. The section over here looks very prone to fracture. And when you compare the density of the tissue, you can see normal bone is going to be relatively strong and dense, where osteoporotic tissue is going to be thinner and less dense. It's a little hard to see these ages here, This is age 55. This is, I think this is 65 and 75. It's a little hard to see. Notice that we're seeing some spinal curvature here. We associate, again, this kyphosis is a very common exaggeration of the thoracic curve. It's very common in people that are osteoporotic. This is just trying to show you a little bit of, and it's a little bit simplified, but what happens to our bone mass and as we get older and as we approach a fracture threshold. When we are relatively young, and we're focusing on females because, as we understand, osteoporosis is a greater issue in females than males, this shows you that our peak bone mass is going to be somewhere around, oops, sorry, it's going to be somewhere in the 30 to 35 range. And it's a little bit, it can vary somewhat. But by the time someone is between 30 and 35, their bone mass is going to be at its maximum. We are building bone mass as we're younger. So obviously our risk of fracture is much smaller. When we get to menopause, menopause is going to change the hormones, obviously, particularly estrogen. And estrogen has a role in this process we'll discuss here in a moment. But at menopause, the estrogen levels are going to drop, and that's going to make our bone loss increase. Osteoclasts are going to be active. Osteoblasts are active too, but just not keeping up with the osteoclast. And this fracture threshold here is sort of this fictional line. It shows you that at a certain point that our bone mass is going to be such that we're more at risk for a fracture. As long as we can stay above that fracture threshold, as long as we can stay, again, north of this line, our risk of fracture is relatively small. Our fracture rate is going to increase if the bone mass drops below that threshold. And as you can tell, the older we get, especially beyond the age of 50 and up until 65 and 70, the rate of osteoporosis is going to be significantly higher. In fact, 30% of American women are going to have osteoporosis between ages of 60 and 70. 70% of women are going to have it by age 80. And we'll look at some risk factors here in a second. So let's consider the types of osteoporosis, because there actually are two types, and then we'll focus on the most common type and its risk factors. The primary osteoporosis is what you think of as sort of the classic advanced aged osteoporosis. Here we're talking about the postmenopausal woman who develops bone weakening when she gets beyond the age of 60 or 65. Though there's another kind of osteoporosis, a secondary osteoporosis, that can be found both in males and females, and that's going to be any factors that are going to be affecting bone health. In particular, someone who has certain drugs or renal failure that can actually affect bone health can lead to bone weakening. So people are taking, for example, heartburn medications or immunosuppressives, lithium for some mental disorders, are going to have some potential weakening of bone, and they can also develop osteoporosis. Another way of thinking about this is not just women get osteoporosis. A man can have it too. However, men are more likely to have the secondary osteoporosis than primary. And the biggest reason for that is as men get into their peak bone building time, their skeleton's going to be heavier than a female skeleton, and therefore they can lose some bone mass and not still have the same risk of fracture as females. So when we look at then the primary risk factors, and we're talking about here about mainly the primary osteoporosis, what are the main ones? Sedentary lifestyle. If somebody has a sedentary lifestyle, and immobility is sort of related to this as well, if they're not moving around very much, and they're not putting much stress on their bones, they're not telling their osteoblasts to build bone. And if their osteoblasts are not building bone, then their osteoclasts are still resorbing it. And if that's the case, they're going to lose bone mass probably at a faster rate than they're building it. We've already seen age. Age is going to be a risk factor simply because when someone gets beyond menopause, then the risk factor is going to increase mainly because of estrogen. What estrogen does is it maintains normal bone density by restraining osteoclasts. Estrogen is going to help maintain normal bone density by restraining osteoclasts. So when we get to menopause, when a woman gets to menopause and she stops producing as much estrogen, the osteoclasts are no longer as restrained, and they are going to start to break down bone faster than the osteoblasts build it. Her diet can also be a factor. If her diet is high in caffeine, alcohol, low in calcium, or low in vitamin D, all these things are going to affect bone density prior to her menopausal years. We say that it's important for a teenage girl in particular, or a young woman, to avoid lots of soft drinks, for example, or to make sure they're getting plenty of calcium so their bone density is as high as it can be before they start losing some bone tissue naturally. Again, postmenopausal goes back again to both estrogen and age and genetics. Caucasian and Asian women tend to have a higher risk for osteoporosis than other racial groups, and the reasons are not particularly clear. It mainly can be just overall density of the skeleton. Caucasian and Asian women tend to have tend to have a smaller, thinner skeleton than another racial groups, which makes them more prone to bone fracture when they lose some bone tissue over time. So how is this diagnosed? How does someone know they have osteoporosis? Well, there is something called a DEXA scan, which is an X-ray that actually looks at two different kind of wavelengths that provides good information about bone mineral density. And the T-score is just one way. It's just a way that scientists report their findings. If someone has a T-score that's at least 2.5 standard deviations below the young adult mean value, that means they're at high risk for osteoporosis. That's a fancy way of saying they've lost too much bone mass. Another way we diagnose osteoporosis is by someone having a fracture. And when they have the fracture and you look at the nature of the fracture, remember this is an example of a pathological fracture, a non-trauma fracture, for example, then we're talking about, that's another way of saying, yes, you do have osteoporosis. And there are some X-ray studies that are being done that are rather interesting, that might be another way in the future you can be diagnosed. Your dentist can actually perhaps be diagnosing you with osteoporosis in the future. There's a study there's a group in England that's doing this, that's looking very carefully at bone density of these panoramic X-rays. And by running these special software programs with these X-rays, they're looking for very minor, slight changes in bone density in the bones of our face. Since when we go to the dentist, once a year or once every couple of years, you have one of these panoramic X-rays, then that's a nice way for them to be able to run a computer program, look at your old X-rays, your new X-rays, and go, we're seeing some bone density loss that might be predictive of osteoporosis. So that your dentist may actually be helping diagnose your osteoporosis in the future. I just want to show you this final slide here with T-score. I'll come back here. I've been away for a while. The T-score here, again, is just showing you how we look at bone density. Someone who has a bone density that's within 1 standard deviation, we say that's pretty normal. You get below that, -1 to 2.5, then that's a low bone mass. You get below 2.5, then that actually is indicating of osteoporosis. So if someone has osteoporosis or someone may be developing it, there's a number of things that we can do. We can obviously increase calcium. We can increase vitamin D. Vitamin D in turn will help us absorb more calcium. There are a number of women who are exploring HRT, hormone replacement therapy, which particularly deals with replacing estrogen when they're postmenopausal. If estrogen was a good thing before they went to menopause because it was restraining osteoclast, then it could be a good thing afterwards, right? Well, yes and no. Depending upon a woman's medical history, she may not want to take HRT. HRT may increase her risk of heart disease. It may increase her risk of certain kinds of cancers. So it may not be wise for every woman to think HRT is going to be the solution or the cure. Now, if she has severe osteoporosis, it's in her family, she's at risk for lots of fractures, she may be willing to take on that risk. And again, there are some women who are very successfully carrying out HRT. They're getting estrogen therapy, and that actually is helpful for them to control their osteoporosis. So there are some other experimental drugs too. Biphosphonates are kind of the rage right now. They actually help also balance osteoblast and osteoclast. That the main therapies, drug-wise, have been to try to restrain the osteoclasts, try to keep them from being too aggressive. As we get older, we simply build bone at a slower rate, but we don't slow down bone resorption. And if we don't slow that down, then over time, we're going to lose bone mass. And I should add one thing here, that all of us are going to, as we get older, develop osteopenia. Osteopenia just means a gradual weakening of a gradual loss of bone mass. Again, for males and females, somewhere between 30 to 35 is when you're going to have your peak bone mass, and you will gradually lose it. Now, exercise, maintaining a good diet, stressing your skeleton in a healthy way helps you maintain bone mass. But osteopenia is simply the natural aging process where we do lose bone mass over time. And the trick is to not lose so much that we approach that fracture threshold and therefore experience a high rate of fracture. Okay, so that is our summary of some major skeletal homeostatic imbalances. Do make sure you understand the difference between osteomalacia, Patch's disease, that you understand what's going on in osteogenesis imperfecta and in osteoporosis. Those are the main ones we looked at. So that will do it for this little lecture. We will have a mastering that will deal with this, and I hope you understood it all. If not, go back and look at it again. Thank you very much.